Here we will see applied mathematics 2. Name of the topic is curve tracing. In curve tracing, there are basically two types. First is Cartesian curve. And second is the polar curve. Before starting the polar form, we will see the Cartesian form. By studying the Cartesian form, we require mainly or we have to focus on the 6 points. Cartesian form or Cartesian curve. So first, the important point is that first is the symmetry. Second is the origin. Third is the tangent at origin. Fourth is the points of intersections. Fifth is the asymptotes. And sixth is the region of existence of curve. So we will touch one by one to these 6 points. So first point is the symmetry. So then curve is symmetric about the x-axis, symmetric about the y-axis, symmetric about the both axes, symmetric about the origin. We will see. If powers of x are even degree, then curve symmetric about y-axis and its reciprocals. That is, if all powers of y are even degree, then curve symmetric about x-axis. See here, in equation, whenever there are x, check its power. If its power are even, it means what? 2, 4, 6, then curve symmetric about the y-axis. And if all powers of y are even degree, then curve symmetric about the x-axis. Again, if powers of x and y are even, then curve symmetric about the both axes. We will see. This is the x-axis. This is the y-axis. So its symmetry is as like this. So we see the symmetric about the y. So this is the curve. Its symmetry is what? As like this. Okay. So symmetric about the both axes as like this. So this is the symmetric of y-axis. This is the symmetric of x-axis. This is about the symmetry. After that, we will see origin. Just put x is equal to 0 and y is equal to 0. If we are getting 0 is equal to 0, then curve passes through origin. You can take the example as like this: xy square is equal to a x minus 1. So put x is equal to 0, y is equal to 0, then you are getting here 0 is equal to 0. In that case, curve is passes through the origin. If 0 0 is not equal to 0. It means what? 0 is equal to non-zero, then curve does not pass through the origin. We know that this is the x-axis, this is the y-axis. You can take example of this. This is the curve symmetric about the x-axis but does not pass through the origin. So we see the one more example which is curve passes from the origin. This is the example which is curve passes from the origin. So this is about the origin. So next point is the tangent at origin. Just take third point whenever curve is passes through origin. If curve does not pass through origin, then there is no need or don't think about this third point. How? If curve is passes through origin, then how you can take the tangent at origin? Just take lowest degree term, lowest degree term is equal to 0. Lowest degree term is equal to 0, then we will get the tangent at origin. So for example, xy square is equal to a minus x, or here a again here. So here its degree is 3, here a square a minus x, its degree is 0, its degree is 1. So here lowest degree is 0. So lowest degree term is equal to the 0. Then we will get the tangent at origin. Here there is no tangent at origin in this particular example. So after that, points of intersection. For points of intersection, put x is equal to 0. Then we will get value of put y is equal to 0, then we will get value of x, and just write down in order here x comma y, x comma y. With the help of that, we can find the points of intersection. Okay, so after this, we will see the asymptotes. There again 2 points are remaining asymptotes. Suppose curve is symmetric about x-axis, then find the highest degree coefficient is equal to 0. Highest degree coefficient equal to 0. Again, curve symmetric about y-axis, then find highest degree coefficient is equal to 0. Okay? Suppose curve is symmetric about the x-axis, then check how many times there is y in the equation, and out of that y, take its highest power, highest degree, and take its coefficient. Its coefficient is equal to 0, then whatever you are getting the value, that is x is equal to something, y is equal to something, that is your asymptotes. What is the meaning of asymptotes? Asymptotes is just a line which is passes from either this x-axis, either positive side or negative side, or asymptotes is a line which is passes from y-axis, that is positive side or negative side. Remember that for asymptotes, curve does not touch. Curve will not be touched to the asymptotes. Okay, remember that. So this is about the asymptotes. Now, last point is very important, that is region of existence of curve. 6. Curve symmetric about x-axis, then find the value of y square. Similarly, curve symmetric about y-axis, then find the value of x square. Find the value of x square. After the finding of value of y square, just finalize the region. Just partition the region. After the partition of region, whenever the value of y square is negative, in that region, curve does not exist. If y square is positive in that particular region, in that region, curve will exist. Similarly, curve is symmetric about the y-axis, then the value of x square. After find the value of x square, just finalize the region of that y. And same way, if whenever the x square is negative in that region, curve does not exist. If x square is positive in that region, curve will be exist. So these are the very important points. Okay. So by using these 6 points, you can draw the curve in the form of Cartesian. Okay. So first is the symmetry. We will summarize this short summary. The power of x is e1, then curve symmetric about the y-axis. Power of y is e1, curve symmetric about the x-axis. Power of x and y are symmetric about the both axes. Power of x and y are even, then curve symmetric about the both axes. Next point is origin. Put x is equal to 0, y is equal to 0. If you are getting 0 is equal to 0, then curve passes through origin. If 0 is equal to non-zero, in that case, curve does not pass through the origin. Third point, tangent at origin. If curve passes through origin, then you can think about the tangent at origin. From all the equation, from all the curve, just take lowest degree term is equal to 0 and find the whatever you are getting the value of that x or value of y, then these are the tangent at the origin. Next, points of intersection. Just put x is equal to 0, we will get the value of y. Put y is equal to 0, we will get the value of x. Asymptotes is just a line passes from either x-axis or y-axis. How to find asymptotes? That is, if curve symmetric about the x-axis, then take highest degree coefficient of y, and if curve is symmetric about the y-axis, then take highest degree coefficient of x. Next, region of existence of curve. If curve is symmetric about the x-axis, then find the value of y square, and if curve symmetric about the y-axis, then find the value of x square. After curve, if symmetric about the x-axis, then finding the value of y square. At that time, remember that whenever the y square is negative, in that case, curve does not exist. And if curve symmetric about x-axis, then find the value of y square. In same way, the value of x square is negative, in that region curve does not exist. And if x square is positive, in that region curve will be exist. So these are the very simple points, 6 points. Okay. So these are some theory regarding the Cartesian form or Cartesian curve. We will see the examples depends upon the Cartesian form in next lecture.